Revision control, also known as version control and source control, is the management of changes to documents, computer programs, large websites, and other collections of information. Changes are usually identified by a number or letter code, termed the revision number, revision level, or simply revision. For example, an initial set of files is revision 1. When the first change is made, the resulting set is revision 2, and so on. Each revision is associated with a timestamp and the person making the change. Revisions can be compared, restored, and with some types of files, merged. The need for a logical way to organize and control revisions has existed for almost as long as writing has existed, but revision control became much more important, and complicated, when the era of computing began. The numbering of book editions and of specification revisions are examples that date back to the print-only era. Today, the most capable revision control systems are those used in software development, where a team of people may change the same files. Version control systems most commonly run as standalone applications, but revision control is also embedded in various types of software such as word processors and spreadsheets, for example, Google Docs and Sheets, and in various content management systems, for example, Wikipedia's page history. Revision control allows for the ability to revert a document to a previous revision, which is critical for allowing editors to track each other's edits, correct mistakes, and defend against vandalism and spamming. Software tools for revision control are essential for the organization of multi-developer projects. Overview: in computer software engineering, revision control is any kind of practice that tracks and provides control over changes to source code. Software developers sometimes use revision control software to maintain documentation and configuration files as well as source code. As teams design, develop and deploy software, it is common for multiple versions of the same software to be deployed in different sites and for the software's developers to be working simultaneously on updates. Bugs or features of the software are often only present in certain versions. Therefore, for the purposes of locating and fixing bugs, it is vitally important to be able to retrieve and run different versions of the software to determine in which version, the problem occurs. It may also be necessary to develop two versions of the software concurrently, while the other version is where new features are worked on. At the simplest level, developers could simply retain multiple copies of the different versions of the program, and label them appropriately. This simple approach has been used on many large software projects. While this method can work, it is inefficient as many near-identical copies of the program have to be maintained. This requires a lot of self-discipline on the part of developers, and often leads to mistakes. Consequently, systems to automate some or all of the revision control process have been developed. Moreover, in software development, legal and business practice and other environments, it has become increasingly common for a single document or snippet of code to be edited by a team, the members of which may be geographically dispersed and may pursue different and even contrary interests. Sophisticated revision control that tracks and accounts for ownership of changes to documents and code may be extremely helpful or even indispensable in such situations. Revision control may also track changes to configuration files, such as those typically stored in /etc. or local etc. on Unix systems. This gives system administrators another way to easily track changes made and a way to roll back to earlier versions should the need arise. Structure: revision control manages changes to a set of data over time. These changes can be structured in various ways. Often the data is thought of as a collection of many individual items, such as files or documents, and changes to individual files are tracked. This accords with intuitions about separate files, but causes problems when identity changes, such as during renaming, splitting, or merging of files. Accordingly, some systems, such as Git, instead consider changes to the data as a whole, which is less intuitive for simple changes, but simplifies more complex changes. When data that is under revision control is modified, after being retrieved by checking out, this is not in general immediately reflected in the revision control system, but must instead be checked in or committed. A copy outside revision control is known as a working copy. As a simple example, when editing a computer file, the data stored in memory by the editing program is the working copy, which is committed by saving. Concretely, one may print out a document, edit it by hand, and only later manually input the changes into a computer and save it. For source code control, the working copy is instead a copy of all files in a particular revision, generally stored locally on the developer's computer. In this case, saving the file only changes the working copy, and checking into the repository is a separate step. If multiple people are working on a single data set or document, they are implicitly creating branches of the data, and thus issues of merging arise, as discussed below. For simple collaborative document editing, this can be prevented by using file locking or simply avoiding working on the same document that someone else is working on. Revision control systems are often centralized, with a single authoritative data store, the repository, and checkouts and check-ins done with reference to this central repository. Alternatively, in distributed revision control, no single repository is authoritative, and data can be checked out and checked into any repository. When checking into a different repository, this is interpreted as a merge or patch. Graph structure. In terms of graph theory, revisions are generally thought of as a line of development with branches off of this, forming a directed tree, visualized as one or more parallel lines of development branching off a trunk. In reality, the structure is more complicated, forming a directed acyclic graph, but for many purposes tree with merges is an adequate approximation. Revisions occur in sequence over time, and thus can be arranged in order either by revision number or timestamp. Revisions are based on past revisions, though it is possible to largely or completely replace an earlier revision, such as delete all existing text, insert new text. In the simplest case, with no branching or undoing, each revision is based on its immediate predecessor alone, and they form a simple line, with a single latest version, the head revision or tip. In graph theory terms, drawing each revision as a point and each derived revision relationship as an arrow, this is a linear graph. If there is branching, so multiple future revisions are based on a past revision, or undoing, so a revision can depend on a revision older than its immediate predecessor, then the resulting graph is instead a directed tree, and has multiple tips, corresponding to the revisions without children. In principle, the resulting tree need not have a preferred tip just various different revisions but in practice one tip is generally identified as head. When a new revision is based on head, it is either identified as the new head, or considered a new branch. The list of revisions from the start to head is the trunk or main line. Conversely, when a revision can be based on more than one previous revision, the resulting process is called a merge, and is one of the most complex aspects of revision control. This most often occurs when changes occur in multiple branches, which are then merged into a single branch incorporating both changes. If these changes overlap, it may be difficult or impossible to merge, and require manual intervention or rewriting. In the presence of merges, the resulting graph is no longer a tree, as nodes can have multiple parents, but is instead a rooted directed acyclic graph. The graph is acyclic since parents are always backwards in time, and rooted because there is an oldest version. However, assuming that there is a trunk, merges from branches can be considered as external to the tree. The changes in the branch are packaged up as a patch, which is applied to head, creating a new revision without any explicit reference to the branch, and preserving the tree structure. Thus, while the actual relations between versions form a DAG, this can be considered a tree plus merges, and the trunk itself is a line. In distributed revision control, in the presence of multiple repositories, these may be based on a single original version, but there need not be an original root, and thus only a separate root for each repository, for example if two people starting working on a project separately. Similarly, in the presence of multiple data sets that exchange data or merge, there is an unregistered trademark TA single root, though for simplicity one may think of one project as primary and the other as secondary, merged into the first with or without its own revision history. Specialized strategies. Engineering revision control developed from formalized processes based on tracking revisions of early blueprints or blueprints. This system of control implicitly allowed returning to any earlier state of the design, for cases in which an engineering dead end was reached in the development of the design. A revision table was used to keep track of the changes made. Additionally, the modified areas of the drawing were highlighted using revision clouds. Version control is also widespread in business and law. Indeed, contract readline and legal blackline are some of the earliest forms of revision control, and are still employed in business and law with varying degrees of sophistication. An entire industry has emerged to service the document revision control needs of business and other users, and some of the revision control technology employed in these circles is subtle, powerful, and innovative. The most sophisticated techniques are beginning to be used for the electronic tracking of changes to CAD files, supplanting the manual electronic implementation of traditional revision control. Source management models. Traditional revision control systems use a centralized model where all the revision control functions take place on a shared server. If two developers try to change the same file at the same time, without some method of managing access, the developers may end up overwriting each other's work. Centralized revision control systems solve this problem in one of two different source management models: file locking and version merging. Atomic operations. Computer scientists speak of atomic operations if the system is left in a consistent state even if the operation is interrupted. The commit operation is usually the most critical in this sense. Commits are operations that tell the revision control system you want to make a group of changes final and available to all users. Not all revision control systems have atomic commits. Notably, the widely used CVS lacks this feature. File locking. The simplest method of preventing concurrent access problems involves locking files so that only one developer at a time has write access to the central repository copies of those files. Once one developer checks out a file, others can read that file, but no one else may change that file until that developer checks in the updated version. File locking has both merits and drawbacks. It can provide some protection against difficult merge conflicts when a user is making radical changes to many sections of a large file. However, if the files are left exclusively locked for too long, other developers may be tempted to bypass the revision control software and change the files locally, leading to more serious problems. Version merging. Most version control systems allow multiple developers to edit the same file at the same time. The first developer to check in changes to the central repository always succeeds. The system may provide facilities to merge further changes into the central repository, and preserve the changes from the first developer when other developers check in. Merging two files can be a very delicate operation, and usually possible only if the data structure is simple, as in text files. The result of a merge of two image files might not result in an image file at all. The second developer checking in code will need to take care with the merge, to make sure that the changes are compatible and that the merge operation does not introduce its own logic errors within the files. These problems limit the availability of automatic or semi-automatic merge operations mainly to simple text-based documents, unless a specific merge plugin is available for the file types. The concept of a reserved edit can provide an optional means to explicitly lock a file for exclusive write access, even when a merging capability exists. Baselines, labels and tags. Most revision control tools will use only one of these similar terms to refer to the action of identifying a snapshot or the record of the snapshot. Typically only one of the terms baseline, label, or tag is used in documentation or discussion. They can be considered synonyms. In most projects some snapshots are more significant than others, such as those used to indicate published releases, branches, or milestones. When both the term baseline and either of label or tag are used together in the same context, label and tag usually refer to the mechanism within the tool of identifying or making the record of the snapshot, and baseline indicates the increased significance of any given label or tag. Most formal discussion of configuration management uses the term baseline. Distributed revision control. Distributed revision control systems take a peer-to-peer approach, as opposed to the client-server approach of centralized systems. Rather than a single, central repository on which clients synchronize, each peer's working copy of the code base is a bona fide repository. Distributed revision control conducts synchronization by exchanging patches from peer to peer. This results in some important differences from a centralized system. No canonical, reference copy of the code base exists by default. Only working copies. Common operations are fast, because there is no need to communicate with a central server. Rather, communication is only necessary when pushing or pulling changes to or from other peers. Each working copy effectively functions as a remote backup of the code base and of its change history, providing inherent protection against data loss. Integration. Some of the more advanced revision control tools offer many other facilities, allowing deeper integration with other tools and software engineering processes. Plugins are often available for IDEs such as Oracle Developer, IntelliJ IDEA, Eclipse and Visual Studio. NetBeans IDE and Xcode come with integrated version control support. Common vocabulary. Terminology can vary from system to system, but some terms in common usage include baseline, an approved revision of a document or source file from which subsequent changes can be made. See baselines, labels and tags. Brancher, a set of files under version control may be branched or forked at a point in time so that, from that time forward, two copies of those files may develop at different speeds or in different ways independently of each other. Changer, a change represents a specific modification to a document under version control. The granularity of the modification considered a change varies between version control systems. Change lister, on many version control systems with atomic multi-change commits, a change list, change set, update, or patch identifies the set of changes made in a single commit. This can also represent a sequential view of the source code, allowing the examination of sources of any particular changelist ID. Checkout, to check out is to create a local working copy from the repository. A user may specify a specific revision or obtain the latest. The term checkout can also be used as a noun to describe the working copy. Committer, to commit is to write or merge the changes made in the working copy back to the repository. The terms commit and check-in can also be used as nouns to describe the new revision that is created as a result of committing. Conflictor, a conflict occurs when different parties make changes to the same document, and the system is unable to reconcile the changes. A user must resolve the conflict by combining the changes, or by selecting one change in favor of the other. Delta compressioner, most revision control software uses delta compression, which retains only the differences between successive versions of files. This allows for more efficient storage of many different versions of files. Dynamic streamer, a stream in which some or all file versions are mirrors of the parent stream's versions. Exporter, exporting is the act of obtaining the files from the repository. It is similar to checking out except that it creates a clean directory tree without the version control metadata used in a working copy. This is often used prior to publishing the contents, for example. Head, also sometimes called tip, this refers to the most recent commit either to the trunk or to a branch. The trunk and each branch have their own head, though head is sometimes loosely used to refer to the trunk. Importer, importing is the act of copying a local directory tree into the repository for the first time. Labeler, see tag. Mainline, similar to trunk, but there can be a main line for each branch. Merge, a merge or integration is an operation in which two sets of changes are applied to a file or set of files. Some sample scenarios are as follows: a user, working on a set of files, updates or syncs their working copy with changes made, and checked into the repository, by other users. A user tries to check in files that have been updated by others since the files were checked out, and the revision control software automatically merges the files. A set of files is branched, a problem that existed before the branching is fixed in one branch, and the fix is then merged into the other branch. A branch is created, the code in the files is independently edited, and the updated branch is later incorporated into a single, unified trunk. Promoter, the act of copying file content from a less controlled location into a more controlled location. For example, from a user's workspace into a repository, or from a stream to its parent. Repository, the repository is where files' current and historical data are stored, often on a server. Sometimes also called a depot. Resolver, the act of user intervention to address a conflict between different changes to the same document. Reverse integrationer, the process of merging different team branches into the main trunk of the versioning system. Revisioner, also version, a version is any change in form. In SVK, a revision is the state at a point in time of the entire tree in the repository. Share, the act of making one file or folder available in multiple branches at the same time. When a shared file is changed in one branch, it is changed in other branches. Streamer, a container for branched files that has a known relationship to other such containers. Streams form a hierarchy. Each stream can inherit various properties from its parent stream. Tagger, a tag or label refers to an important snapshot in time, consistent across many files. These files at that point may all be tagged with a user-friendly, meaningful name or revision number. See baselines, labels and tags. Trunk, the unique line of development that is not a branch. Updater, an update merges changes made in the repository into the local working copy. Update is also the term used by some CM tools for the change package concept. Working copy, the working copy is the local copy of files from a repository, at a specific time or revision. All work done to the files in a repository is initially done on a working copy, hence the name. Conceptually, it is a sandbox. See also, change control, changelog, comparison of revision control software, distributed revision control, list of revision control software, software configuration management, software versioning, versioning file system, notes. References. Bibliography, Colin Sussman, Ben. Fitzpatrick, B.W. Pilato, C.M., Version Control with Subversion, O'Reilly, ISBN A0-596-00448-6. External links, Visual Guide to Version Control, Better Explanida. Better SCM Initiative Comparison at the Wayback Machine. A useful summary of different systems and their features. Sink, Eric, Source Control, SCMA. The Basics of Version Control.